So to do this, we use something called an access control context. And in fact, this is what the underlying JRE uses all along. So the access control context provides security context information. It essentially gives us back the complete security context. So if we're on a given thread in a given stack frame and we ask for the access control context, what we'll get back from this is the complete security context for where we are currently. So where we are in the stack frame, where we are inside the call. And the access control context is actually what the access controller uses when it does its stack walk. For each stack frame, the access controller actually reaches out, obtains an access control context, and uses that to do its security checks. And the way it does the security checks is by calling access control context.checkPermission. If this call on the current frame succeeds, we go to the next stack frame. On the next stack frame, we get an access control context, we call this check permission, and then we keep walking up the stack frame. And another job of the access control context is to manage the protection domains. So the access control context will eliminate duplicate protection domains, for example, to make sure these things aren't checked multiple times. So how do we get an access control context? Well, we can get one of these things in one of three ways. We can call access controller getContext, and that gives us the access control context of the current thread that we're running on. We can also do a new access control context and pass to it an array of protection domains, or we can create a new access control context and pass this something called a domain combiner. When something tries to use the access control context, they call the domain combiner's combine method, and it's the job of the domain combiner's combine method to combine together the protection domains that are going to be used by this access control context. So you can see in the first case, we get given access to the access control context that's used by the JRE by default. In the second case, we can create an access control context out of clean cloth. And in the third case, we can create an access control context by using information from the current control context and other information that we provide. So where is this typically used? Now we can use this directly. So we can use the access control context to do a check permissions. And again, just like the access controller, it will throw a security exception if the check fails. However, this does not do a stack walk. So the access control context here will just check that this stack frame has permission. So if you need that fine-grained check, you'd use the access control context check permission rather than the access controller check permission. And we see some code here. We're not seeing how we get the access control context here. We just know we have one. But once we have one, we can call this check permission and we can pass it a property permission. So in this case, we're looking to see if I can read or write for a given property. Now, the most likely use of access control context, though, is to do something called a privileged block execution. And what this does is it sets the context on the call stack and essentially prevents the stack walk going any further. The way we do this is by creating something called a privileged action. The privileged action has a run method. We do the check inside the run method, but that prevents the stack walk. So we only check things inside the run method. So the code looks like this. We call access controller.doPrivileged, and we create a new privileged action with a run method. When we do this, the run method will execute. Notice that we can pass this an access control context to use inside the run method, or we can just use the current access control context. Either way, the code that runs inside this run method, the access controller permission check is done here. We don't try and walk the stack any further. So earlier we saw this slide, and here we said that we have two methods on the stack frame. We have the main method, and then we create a file writer, and we have the file writer's write method. And we said that the file writer is always trusted, because the file writer comes from the JRE libraries, that location is always trusted, but that the main method may not be trusted. And in this case, we said that we have a full stack walk. So when we call writer.write, that will be trusted, but that's not good enough. So we walk up the stack frame, and main is untrusted, and that throws an exception. So we said we had this. We call main, main calls writer.write, main is untrusted, but file writer was trusted. And this was an issue. And it was an issue because, as we just said, if one of those things on the stack frame is untrusted, then we'd like an exception to be thrown. However, sometimes that's not the scenario. Sometimes the scenario is that something on the stack frame is untrusted, but there is something trusted on the stack frame that you want to always trust regardless of the context. So imagine a scenario where you're trying to audit code, for example. That audit class might always want to be trusted. You always want to write the audit message out, regardless of whatever else is on the stack frame. And that's what we get by using privileged execution. So let's take a look at a demo of that now.